A survey of 30 emergency room patients found that the average waiting time for treatment was 115 minutes. Assuming the sample standard deviation is 42 minutes, construct a 95% confidence interval to find the population mean wait time, which is we want to estimate the population mean by using the sample mean. So this is a confidence interval question. So this question, we only getting the information. It's the mean time, waiting the mean time. When we use those 30 sample, that's a subset, right? Only 30 inside of the subset. We run those 30 subset information to getting the sample mean. The mean time is 115 minutes. So this is the best point estimate to estimate the population mean. And the standard deviation is 42. So from here, from question, we don't get any information of the population standard deviation. We don't know this information. So when we run the confidence interval test, estimate the mean, we can either go with a z-table or t-table. However, this one, we only can go with a t-table because we don't know the population standard deviation. Okay, so when we finding using the t-table to finding the t-score, because when we run the confidence interval test, it's always two-tailed test. So whatever test you use, chi-square test, z-test, or t-test, you always has the two-tail, which is alpha over 2. So since the confidence interval we know is a 95%, that means finding the alpha has a 5%, but this is a two-tail. So we have to divide by 2. So each tail, the alpha occupy 0.025. When you go look at the t-table, finding the probability is 0.025, which is on the top cross row. You go find the probability 0.025 to intersect with the degree of freedom. Degree of freedom is 29 because the sample size is 30. So finding the intercept point by using the z-table of these two information, you'll get the t-score. T-score is not a 1.96. When you go with the z-table, yes, that is a 1.96 when the probability is 0.025. But you cannot use a z-table. You have to use a t-table. So the mean Bob used the wrong. He made a mistake using the wrong table. So we cross out 1.96 because that is not the right value. If the true score, the true value of the t using the t-table, this point it should has 2.045. So same way 2.045. So we use a mean point sample mean point estimate to plus minus the t-score is 2.045 because when you have the t probability 0.025, degree of freedom equal 29, the t-score is 2.045. You can look at your t-table. And then you multiply 2.045 with the 42, that's the standard deviation of the sample, divide by square root n. So multiply these two, divide by square root n, you'll get a number is, the number I have here is 15.68. So same way, this number is 15.68. And then you use the 150 to plus minus these two numbers, and you'll get the lower bound with the confidence interval is 134.32, and the upper bound is 165.08. 165.68. Okay, so this is 68. So then we can describe our conclusion. I'm 95% confident that the mean wait time for emergency room treatment is between 134.32 minutes and 165.68 minutes. So this is a way you give the right confidence interval with a 95% based on this question. So part A, using the complete sentence to describe the mistake and briefly explain what Bob must to do to correct his solution. So Bob used the Z distribution table when he's supposed to use the T table. So the way he can make the correction is change the Z score into the T score and recalculate the number. And using the correct method you found in part A, construct the actual 95% confidence interval. So the population mean estimate time with a 95% confidence interval is between 134.32 minutes and 165.08 minutes. C. Using the complete statement, interpreted the new confidence interval found in part B. So you can say 95. So 95% confident that the mean waiting time for emergency room treatment is between 134.32 minutes and 165.68 minutes. So you have pretty much the same example. You can look at this one and produce your own question. Now we look at the other one. A company wants to decide how to label their bags of food, the dog food. The filling machine inevitably experiencing fluctuations in filling. So a quality control manager randomly selects a sample at 12 bags of dog food from the storage facility and measure their content. So she obtained the following data. Now confirm whether it's an outlier or not by using the box plot. Determine the sample mean and the sample standard deviation. Show the work to construct the 90% confidence interval for the population variance. And using the complete sentence, interpreted this solution. So getting the out to determine whether it's an outlier or not, you can simply to plug in all the data into the calculator. So when you go to stat, the first one is added. So you input all the data under L1. Once you finish the data input, you can go to the source data. Okay, so you can have your data in the increasing order. So hit enter. All the data is listed under L1. So you click on blue, which is second. Input the number 1, close it, and hit enter. So you'll see done. That means the data has been sorted. Now click on step one more time. Go to the count. Click on one variable. So enter, enter, enter. Now you'll see the mean, the sample mean is 7.98. The sample standard deviation is 0.37. If you continue to scroll down, you'll find the minimum. You'll find the Q1, median is Q2, and Q3 is 8.26, and the maximum is 8.53. So now we interpreted those information into the box plot. So I have the Q1, Q2, and the Q3. The minimum is 7.36. The maximum is 8.53. In order to know whether you have the outlier or not, we have to use the IQR multiply 1.5. And IQR is getting from Q3 minus Q1. If you want to refresh your work, you can go back to check chapter 3.5, I believe. So IQR, when we subtract these two numbers, we get a 0.5. When I multiply with 1.5, it gives me the interval range is 0.75. So 0.75, that represents if I use a Q3 to add 0.75, that would be the upper bound, which is any data greater than 9.01, we count that as an outlier. When I use a Q1 to subtract 0.75, it will turn to the lower bound. So any data outside or in front before the lower bound, we count that as an outlier. Unfortunately, if you look at the data here, we don't see any data is outside of the upper bound or lower bound. They're inside. So no outlier for this question. Now, determine the sample mean. Sample mean is here, X bar 7.98. Standard deviation is 0.37. Part C, construct a 95% confidence interval for the population variance. So we have to estimate the population variance. And here, the right-hand side, the formula is n-1 multiply sample variance divided by the chi-square to the left. And the left-hand side bound, same way, you have n-1 multiply sample variance divided by chi-square to the right. Okay, so we solve for this one. n-1, we have 12. N is 12, which is, when I subtract 1, this is degree of freedom. Multiply sample variance, which is 0.37. You do the square. So same to the left, you have 11 multiply 0.37, do the square. Now, finding the chi-square, using the chi-square table to find the chi-square value here, we have to consider the alpha level. Alpha is 10%, right? And keep in mind, we always take the half of the alpha when you do the confidence interval test, which is 5%. So this is 0.05. So if you are looking for the chi-square right-hand side, this point, you need to use the 0.05. Look at your chi-square table. Looking the chi-square left-hand side value here, this one you go with the 0.05. However, this one you have to use the 0.95. And your degree of freedom, both of them, they are 11. So the number I have to the right here, I got a 4.575. And the left-hand side chi-square value here, the right-hand side chi-square value here, I have 19.675. So when I calculate these two numbers, here I got a 0.069, and here I got a 0.297. So this is the variance, population variance, when we do the confidence interval 90% of the confidence interval. We estimate the population variance is between 0.069 and 0.297. So using the complete sentence to interpret the interval, we are 90% confident because my time is running out. So I will just explain here, just tell you here, and you can write down the statement by using the example, this one. So you can say we are 90% confident we are 90% confident the population variance is between 0.096 and 0.297.